In this video, we're looking at identifying functions from relations from the Functions and Lines pie slice in ALEX for Algebra 1. So it says for each relation, decide whether or not it's a function. So what we need to do is look at the domain, that's all of our x values, and the range, all of our y values. And it doesn't matter what the letters or words, anything like that are in your domain and range. All you're looking for is, does every value in the domain have exactly one corresponding value in the range? Okay, so the first thing that you can do is look at the domain, and if every single piece of information in the domain, so each of our elements in the domain is unique. So here we have N, W, S, and T. Each of those is unique. So that means that each of them will only have one value in the range. And it doesn't matter if, like, for instance, the W has the same value in the range as N. So notice that N and W both have W in the range. That's okay. This, because all of the elements of the domain are unique, is a function because each element of the domain has exactly one value for the range. In relation to, again, we have -2, -6, 9, 4, and -4. Because each of those is unique, we know right away that this is a function. Looking at relation 3, this time we don't have it laid out in domain and range. Remember, domain is your x values, range is your y values. So the domain is 5, 5, 5, and 5, and the range is -6, -3, 5, and -8. So notice that all of our elements from the domain are the same, and they have different values. So if elements of your domain are the same with different values, then that means that this is not a function. In relation 4, again, they just gave us ordered pairs, so we have to look at all of our x values for the domain. So our domain is Z, A, W, and U, and our range is 9, -7, -2, and -3. All of our elements in the domain are unique, so we know right away that this is a function. Going over to this relation, again, we have it set up a little bit differently here. Okay, instead we have the domain and then we have arrows pointing to the range. The range only has 3 values, but we have 4 different values for the domain. Again, we look first to see, are all of the values in the domain unique? G, M, A, and C. Okay, so we can rewrite that as a table. So G, M, A, and C, and then look at where the arrows go to figure out what the range is. So for G, our corresponding value is -9. For M, our corresponding value is -9. For A, our corresponding value is -7. And for C, our corresponding value is -4. Okay, again, because all of our values in the domain are unique, then that means that we have a function. for this relation too, and we'll make a table. So for our domain, we have k, but k has two arrows coming off of it, so we need to write k twice. Then we have r, x, and e. In our range, k has r as one of its values for the range. K also has x for one of its values as a range. And because we have two elements in the domain that are the same with two different values for the range, that means that it's not a function. Okay, so if you have the same value come up twice, just like over here, we had 5 come up multiple times with different values, that means that it's not a function. So over here, if you see a value in the domain that branches off to two different values in the range, then you know it's not a function. For relation 3, right here, each of our values in the domain are different. And even though they all have the same value for the range, because all of the elements for the domain are different, each one has its own value for the range, that means that it is a function. In relation 4, we have to take a look. 9 comes up twice with two different values for the range, so we know right away that it's not a function. It also has -1 comes up 3 different times with 3 different values for the range, so we know that it is definitely not a function.